Atari at number 42, Atari Panic for Terra 2600.
Hello my fellow Padawan, I was not stolen. I prayed for it, but they just did not take me. As I promised, I'm gonna talk about the programming of my darling again, about the story that turned me from a nice gamer into a scary Techzilla. I don't want to go back to the basic of the basics, so if you had erased unnecessary bytes from your brain, you can watch my earlier video again. For lazy people, you can find the link in the description. For my 200 subbers from abroad, for that video you have to settle for our Finnish Ugric language and English subtitles. Sorry about that. Every 2 weeks I see the lame joke about that the Atari 2600 had no memory, but it's actually bullshit. It has 128 bytes of memory without expansion. For a really basic game, it's more than enough. You should learn how to slice and recycle. You won't waste a whole bottle of milk for one glass. With the VCS, the most frightening part is how the graphics are done by the machine, or I should say how it lacks graphics creation. Let's take a look at the VIC-20. This machine does not have any graphics mode. You have a matrix of 22x23 with 8x8 character, each with a unique color. I wrote a really short code that fills the video memory with all the available characters and 16 colors. If you are interested in the machine, you can check my older episode about the computer. The Atari 2600 is based on a really different architecture. In 1977 they even halved the 8KB addressable ROM of the time, and they cut more costs by reducing the size of RAM, which was really expensive back then, so they had to forget about frame buffer. So the poor programmer have to make the script that draws the screen. If the engineers have put in some effort, you should just set some pointers and some positions and call a special command to start drawing, but no, they were like, if you are stepping into a nail, you should just impale yourself. The programmer has to do exact timing and syncing in the 3 periods of the cathode tube's work, and while drawing, counting back and place the objects, and there is no exposition, so you have to calculate that in the previous scanline with a loop. You also have to store sprites as an array and load the lines in every scanline, and you have to do timing every time to get 76 cycles or waste 3 cycles and call VSync. But all these disadvantages can be turned the other way. You can place one of the objects in every line and you can change the registers on the fly. You can even alter the rule of repeated and mirrored playfields, and you can even turn a triple of sprites into 3 different ones. You just have to be the bandman who will do the timing. It's even easier to guess the lottery. And you can also change the colors in every line, speaking of sprites, playfield or the background. But of course it's more than 76 cycles in a line can tolerate, so you have to think of 2 or 3 lines in a kernel. Have you ever told you about the 48 pixels big sprite? The one with interlaced 96 pixels is much more pleasing for the eye, but I did not create my own kernel for that. It seems to be easier, but the code will be much longer. In the 48 pixel version, the P0 and P1 is tripled. They are 3 circles away and you have to shift P1 with 1 pixel to the left. And these commands HMP0 and HMP1 don't like to work properly. The hardest part is that you have to rewrite the GPR0 and GPR1 register in the exact time, and you also have to sacrifice the stack register, so if you won't recover it from a temporal variable, the return will make you fly to another dimension. The funny part, you have to use an undocumented illegal opcode for the pointer loading lex. So you are gonna load the value into A and shift it to X, and you are gonna use only 6 cycles instead of 8. To raise the fun, even with your care, the 0th bit of the first sprite or the 7th bit of the 6th sprite will be corrupted, so you have to use tricks here. Set the color of the playfield to match the background, place the ball on the 0th bit of the first sprite, erasing it. To restore the bit, you have to use the Messiah 0 by shifting the GRP 0 bit to the right and using Eeyore on the first bit and save the result. Is it done? Oh my! If the sprite is tripled, so will be the Messiah, so you have to set PF1 to 11111111 and PF2 to 00000001 because on the 2600 one is read straight and one is read reversed. I read it somewhere that the engineers could only make the timing exact this way and the programmer can suck balls. By the way, if you don't want to make it colorful, you can just make it as a one-line kernel. This is still pretty easy. Have I ever told you, if you cross page boundary, the high byte of the address won't be the same, so loading from an address with a pointer will take an extra cycle, so your whole timing becomes dust.
Okay, fine, I'm cool, I'm fine.
You know, maybe I should not complain about the knife in my bag that I had put there myself, but you know, it's not a surprise that the homebrew same for the 2600 was so lukewarm until 207, but then came Battery Basic and everything changed. Battery Basic, let's call it BB for short from now, saves you from the most horrible part of development and gives you a nice nostalgia. It tries to give you syntax of the classic 8-bit BASIC era. Of course they were different in many ways. First your code compiles into assembly, then turns it into binary, so you can test it immediately. Of course it would waste some space as all high-level languages, so you should check it if you can manually compress your code, or is there some part that is the same at more if-then statements. In assembly it's really a piece of cake to make these jumps. No joke, you can easily free up 300 bytes in a full-staffed 4K bank. How funny to talk about this in 2020. The biggest advantage of BB is its high readability. It's the main reason why I started believing in myself and I'm attending an official programming course right now. It also has a lot of macros, so it feels more like an engine than a language. With the standard kernel, the commands to change the playfield are really handful. The applications for creating sprites and playfields make things a lot easier. On the audio side it's not giving much, but it's free, so I don't want to complain. The only thing I don't understand why it uses 2 bytes for volume and waveform. They are both 4-bit numbers, so they fit into 1 byte. The kernel for designing title screens is one of the most impressive things ever made for the system. Even without great skills, you can create nice visuals. The only thing I don't like, it generates a folder with the files and the labels are static, so without a trick you can only include one title kernel for one project. I have to admit that mostly a title kernel needs a whole bank, so you couldn't include too much of them anyway. So, if you could keep up, BB gave you the illusion that you have a real basic home computer at home with this easy to use language and the applications they developed for it. You had no need to handle the screen sections and the scan lines. It felt like you are only managing frames. But this will also decrease your possibilities. BB offers 2+1 kernels for the developer. All of them have a game section at top and an indicator section at the bottom that only has a 6-digit score by default that contains binary coded decimal numbers, and also you could insert a mini kernel as well. Or as many as you want, you can easily merge them into one. These are indicators for life and points, keypad controller readers, they even made a text module. This mini kernel thing is a little too fixed, it has to be on the bottom, but you know, many wear the underwear on the outside or eat pizza with kiwi on top. As I mentioned, there are 2+1 kernels, but what are these? To make it simple, what is more important to you, more sprites or anything else? Should I be blind or deaf? The multisprite kernel is really simple and well designed. It was added to the program after some year of the first release. It has only one player 0 sprite, but there can be 5 of player 1s if they are not on the same scan line. If they are in V-blank, it will be calculated which one to flicker. This is suitable for most games if the enemies are moving in their own lines, and with the sprite doubling and tripling you can feel it like if there are more of them, but of course if you are not lazy you make them shootable one by one. But this is the only advantage it has. You have mirrored playfield, no multicolor, just a plain one you set earlier. Okay, there is a hacked one that lets you change the background colors, but if one sprite's vertical position will be the same as the position of loading the new colors, it can ruin the process. And standard kernel is the complete opposite. The playfield is asymmetric due it is stored in the RAM, and this makes it possible to change it bit by bit. So this is basically the so missed frame buffer. But here the size of the screen is fixed at 11 lines, and by default titles are 8 pixels tall. That is really bulky, so if you add Sarah Superchip support, which will eat up the ROM addresses of between 1000 and 10FF, so the first readable 256 bytes and you lose this amount in every bank. But this will allow you making a more pleasing display for the eye. The playfield stored in RAM won't stop the last bank, where BB automatically places the display kernel and the mini kernel, but you know only newbies won't do a bank switching and place the mini kernel in another bank, then doing a return other bank. Do all you can do for the more detailed sprites. Above that you can change the height of the missile and the board and the height of the playfield lines. You can make sprites colorful, change the colors or change the background color line by line. Of course these are not available at the same time and you have to make sacrifices, like Missile Zero in most cases. If you want to have two multicolored sprites, you have to get rid of both missiles because you can't vertically delay them because of the lack of the registers for that. For me, the standard kernel is a mystery how it can even work. It does not have any VSync. Strangely, for my first games I only used the standard kernel, but then I just cared about the multi-sprite one. But after that, for the last two games, I had to go back for the standard one because I had to use the asymmetric playfield. And now I want to show you what I had created last time in adding some tricks for BB. Why are you looking at me like serial killers? Oh, I get it. I thought about 2+1 kernels, right? Oh my. Correct, there is a DPC Plus kernel for BB, but to be honest, I never used that one. DPC Plus is an ARM chip that is an upgraded version of Pitfall 2's DPC and calculates a lot for the 6507 CPU, so you will have a lot of cycles for things you wouldn't do the other way. DPC Plus is fixed at 32K and you get the 128 bytes of extra RAM by default. The share of work will allow you to change the value and color of the playfield, the background, the sprites. For the sprites you also have 9 of the P1 sprites. It's like being proud of your high-level complex Italian examination certificate while Italian is your mother tongue. And yeah, I had a girlfriend like that for several months. If you create all the methods in assembly and you code the ARM chip, DPC Plus is really beyond what you can imagine. Just take a look at Mappy, or there's even a ray casting engine as well. But in BB, using the DPC Plus is mostly about avoiding learning, ignoring tricks and laziness. That after every DPC Plus coded BB game, God kills a cute hippo. Because someone has to like hippos as well. 50 years ago they had to use the switches on the front panel and the typewriter terminal to enter the code. They did not have even DPC Plus inside. Of course, even in BB you can use some assembly and create enjoyable games, and what should I show you to represent it other than my last game? To be honest, in this form I'm not even worth to review it, but maybe 5 minutes of Slavorum will be enough. Playing this really cheeky bricky game would make every Western spy be honored by our proud fatherland. Oh yeah, the old classic Moscow Night, the only more beautiful way to listen to it is the Red Armature version. The very first game is about controlling the force reactor, of course, planning simplicity, safety first.
Safety first.
You turn the reactor on and off, a little xenon poisoning is always needed. You push the turbines over the limits of water would become steam, and of course, remove the rods, they are just in your way. If performance goes over 20,000 gigawatts, just pour some vodka. The rods will be stuck even if you press the AZ5. Babushka will be really surprised watching the pink milk. In the second game you have to balance more on the stupid Western spy mimicking the squatting object. If you can split the sunflower seed into the trash can 4 meters away, this won't be a challenge to you. If you cannot split the 4 meters, you won't get your pass for supper. In the third game you have to sink the cooling water of the reactor. Oh, like we did in my childhood. Before the hot magma reaches it and the steam explosion will give toxic ray for the environment, hide into the lada, it survives every fate. And there are that radiating particle that is part of every traditional Slavic breakfast, but somehow here it just kills you. In the fourth game, everything becomes bulky and huge like in real life, and the backgrounds move left and right. It feels like a more detailed game on a decent computer. The quest is really easy. You shoot the radiating dogs, and as your mind can't take anymore, the background becomes gloomier and the music becomes more distorted. It's a song called Chorny Voron, which was sung by the comrade in the series.
Что ж ты вьешься над моею головой?
You can turn off the distortion if you are not used to the cheap Soviet radios, but True Govniks turned off the music and listen to hard bass. That is not possible on the Atari 2600. Or is it? In the last game you have thrown the graphite off the roof because what kills a Western robot is no challenge for a Soviet soldier. If you ever were in a Soviet pioneer camp, you did this already. If you get stuck like the poor comrade in the series, remember, this is not a bug, but a feature. But because I want to continue this review in Western style, I have to drink this deslavizator Western stuff. One moment, and I will be back. So this was a really long project that took 3/4 years, and it was based on 5 key scenes of the Chernobyl series I really loved. And to be honest, I rarely follow series. I got many critics because in spite of the serious topic, I made it arcade style. While doing the game about the liquidators, I had the thought that maybe I should remove the score digits because it's not fair to get points for killing animals. But I did not change it because, you know, it felt really harsh that you can't really win, just make your death more distant. And in these years, I learned what mostly homebrew players and buyers want to get. For myself, I prefer complex games and ideas that make it into vintage graphics and audio, but most of the people following the homebrew scene have different taste. Most of them want to get the original atmosphere, not to mention the arcade quality ports made via hardware upgrades. Those were the things they wanted to get as kids. Abyss of Chernobyl was some kind of learning process for me. I managed to create a universal 48 pixel kernel that I know how it should be used. With one color only, it works as a one-line kernel, but with shades it must have 2 lines. This can be used for colorful images where you load the colors and you add the luminance to them, as you can see here with the game over screen. The other thing that seemed to be work is the line indicator, and because only the data of the first 2 sprites has to be updated, you don't have to make it a 2-lines kernel. The life indicator with 6 items will be the same, you have to change the graphics data only at the beginning of the lines. From this, the interlaced 96 pixels, 12 sprites kernel is only one step away. That one would take more typing, but because the sprites are not in each other's binary S's, you have a better chance to override the sprite registers, but you have to change the horizontal positions every line, so I don't have experience with it. I have already ordered my straitjacket from AliExpress, safety first. This method is useful for displaying pictures, indicators, as the other one, and you also can create a type-based game field, as you can see in RoboMechanic. I have some special ideas too! For example, a visualizer for music that can show the waveform or the volume of different frequencies. This one will be used in my last planned battery basic game called Metalhead at the moment, because I really need to put the playfield into the RAM that won't be supported by my Atari 2600 environment. And what's the difference, you may ask? As I already mentioned, the standard kernel of BB loads the playfield from RAM, while the multisprite kernel loads it from the ROM, so in the case of using RAM you load values via the overscan and the playfield registers are modified at every start and middle of the scan lines. The other one only changes the pointer during the overscan and the playfield displays in the same bank as the display kernel. In multisprite kernel you only read values at the beginning of the lines, while you would have enough cycles to do other stuff. My plan to do in theory is to make a non-mirrored playfield that could be loaded from the ROM, so you will have to load PF1 and PF2 at the beginning of the line, and I have to read the new PF2 and PF1 at the 35th cycle. I also would prefer to change the color of the playfield and the background in every line, of course from the ROM, and I would like to have 4-player sprites. Holy Glavis ultrasound, there can be more than 2 sprites in a line? Nope, we have to be clever. Because before you gonna do the wall display thing, you should set the sprite data to 0 and set their horizontal positions so you don't have to jerk around, then save their vertical position into a temporal variable and its color as well, and if the drawing is done of 1, you have to do the whole thing again for its pair during the display section. So my plan is to have 2 of each player sprites on one screen. If 2 of the same sprites are on the same scan line, of course you have to use a timer, so in odd frames you draw the first, in even frames you draw the other one. Of course, I only want to do that. You can also have double missiles, ball, and you can solve this flicker thing in the overscan. When I mean lines, I mostly mean 3 of them. I want to calculate with this many because I don't want to fill the whole ROM with these, but I don't want to have a bulky resolution either. I have some other ideas as well. It's not sure that they will be included in the final version. For example, a slot machine that allows you to change the sprite index separately at every sprite. It's like the fuel indicator in Cosmic Commuter. And I don't want to keep it as a secret that there's a module added to BB, and I have to rethink that, because that's one of the most important, yet the most missed element on the VCS, the print command. Hello world! The Atari 2600 does not have character-based display, but with some tricks you can create a text of 12 characters with 5 pixels tall, 4 pixels wide simple letters, but that won't be easy as the previous modules, because we would have to store the pixel registers in a temporary variable, or we could use the 96 pixel wide interlaced kernel with 12 sprites. That uses the classic method to draw the text created from 12 characters, but we are not using temporal variables, but also we have to make it 8 pixels tall and 1 character will use up the whole byte. These kernel elements can be placed on each other like Lego, so Steve can really easily create his dream game, but how can he really do that? You will need additional programs and a language to write your code. If you look at the development applications of BB, it's not bad actually on the graphics part. I don't want to add more. A sprite developer with merged 16 pixel wide sprite development support and the playfield creator with foreground and background colors should be enough. But BB was really weak on the audio part. I already done a MIDI and wave converter for the system. I want to rewrite them and add many features to them so you would make the TIA play for precise and lovable sound. Also, I want to add support for mod and VGM formats. Because one of the games I want to port stores its music in VGM. I had already tried to make the sound of the TIA more precise by changing the octave every third frame. It's a lot better that way, but if I get myself together and measure the frequency of every tone and vibrate the sounds together, I can cheat the human hearing. Even if I can finish this, I still have one really important task yet. If you are familiar with chiptune, you will know about trackers. There is one called TI-A tracker for the 2600 and it's used more or less with success. My main problem is, as I can't really find the notes on the neck of the guitar, I'm not really a fan of trackers either. As I was younger, I learned to use a very late version of EJ. That one had the possibility to create your own samples from original sound effects, and you really could create your own music. If you could create your own samples using pre-made drum and head effects, you could use the hardware of the VCS in a pro way, and as I mentioned, there will be a correction for frequency as well. Wow! All the TI-A will be burned before I finish all this stuff. Also, there is another really important application, the memory controller. Today you really don't have to care of this, you have a lot of memory to stuff, and to be honest, even in the 8-bit world, owning the maximum 64K available would turn me into a codeminator, but this time I only have 128 bytes. By default, if you start a new project, the application will run in safe mode, but I'm pretty sure that all of you will turn that off immediately. Python masters won't know about unsafe mode, and even C# and mages won't use it too often because, as allowed, the environment won't save you from overwriting already used memory addresses on the VCS that will produce really strange things or reset the whole system. This is the most beautiful part of retro programming, that you won't know what you have screwed up. So let's get your magnifying glass and your contramal drops. Okay, but what kind of variables can you declare? I have to be very clever as designing this, because if you don't know it already, a variable is just a pointer that is connected to a memory address. In BB, you work with whole bytes, and if you had already declared the byte by putting a number into curly brackets after the name, you can change a single bit of the variable. So if you were brave enough to slice the byte to bits, but you had no real method for controlling more of them at the same time. And in my country, on the standard keyboards, you have to press Alt+B for open curly bracket, and that's the same as the command in BB for creating bookmarks. I were thinking a lot how complicated my life should become. I got the idea that I should add 4 variable types. Bit is really self-explanatory, I could call it a boolean. It can be true or false. Double bit is a pair of bits, mostly I mean 0, 1, 2, 3, 4, 5 and 6, 7, so you can save numbers between 0 and 3. Nibble splits bytes into 2, one nibble can contain a number between 0 and 15. The word contains 2 bytes, it's made basically for pointers, mostly it's not for the developer but for the system. My other question on my mind was handling arrays. You could put mutable ones in the RAM and immutables in the ROM, like a sports tailpipe on a travel. And there is the big question, in the age of object orientation, should you use Goto and Gossip? If I really want to be strict, there's only one case, and I'm not talking about the fresh code spaghetti kernel I made, but about the code the user entered. And that is as the developer leaves the room for the next level, for the game over screen, goes back to the main menu, etc. What is similar to it is an automated loop that forwards back to the cycle to the beginning of the overscan after the draw scheme section was done. The third one, which has a more sophisticated object-oriented method, is as you call a method and then you return to the original loop, doing backswitching if you want. Other important part, in my opinion, that you should be able to do before display kernel call a unique vblank coding, that was not possible in BB, you could only do a universal vblank. Another important task is the pseudo random number generator. There is a really cool method in Stephen Huck's book. If you add a simple AND command, you can make it limited to the nth power of 2 minus 1. I also will sacrifice one memory address to the timer that increases every frame. Adding its value to the random number will make it more random. The other method is randROM, where you can generate a pointer by using random and timer as low and high bytes, and by that you can load the value on that address. Timer has even one more purpose. If you use here the end as well, you can create a comment for in every nth power of 2 minus 1 frame do this. Okay, we progressed a lot. The only things left is a syntax that's easier to understand for common folks than assembly. You know there are more programming languages than programmers. You can choose from ancient ones to high-end, also from easy to read ones to Madman's Horror. And for that reason, I decided that we should follow the path of Jupyter Ace and use Forth as the high-level language. No, please no, that was just a joke, I will use Fortran for the interpreter. No, please, no, stop. It's still used in meteorology and in scientific calculation. I have a couple reasons for doing this. First, I have the pleasant memory of looking at unfamiliar languages, and there was an exemplar written in C++, C and Fortran 95. Don't have to say, as reading them, only Fortran 95 was so easy to understand that without knowing the language, I understood what the example does. I'm a bit fed up with this basic fever, and I also want to master Fortran, so there's a personal motivation. And also I found it that this is one of the most logical languages. It can handle cases, subroutines and functions, while BASIC is not really capable of doing that. Also, VCS is mostly handling whole numbers between 0 and 255, and most games are only about changing the memory addresses and CPU registers. That is something Fortran is really good at, and Fortran loves to declare variables before using them. That is a task of our memory editor anyway. And again, there's one more reason why I prefer Fortran to C variables, because it handles subprocesses with tabulators. There are no curly brackets. Those are just making my eyes bleed. Okay, I guess this was more than enough, so I close this topic. I will have to finish this environment because I want to make this the final exam code at school, and I also want to piss off the people checking attendees and employees who are only caring about years of experience and some keywords. But because this combination of family, work and school really killing my free time, instead of the mid-70s computers and their cryptic way of programming, I'm gonna grab one of the most valuable and strangest game in my collection, Manjam. Let's have a bite of the taste of Italia.